Okay, let's solve this question. A boat sails 6 kilometers from a point X on a bearing of 65 degrees and thereafter 13 kilometers on a bearing of 136 degrees. What is the distance and bearing of the boat from X? Now, what you do to any question on bearing is to straight away check what they ask you to find. They will always ask you for distance and bearing from one point to another. I'm going to explain some facts that matters. If they ask you to calculate the distance, it's all about the sides of the triangle, any of the sides of the triangle. Here is where we have the problem when they talk about bearing. I told you bearing is just the angular relationship between 2 points. Okay, starting from the north pole and clockwise direction. What I mean by north pole is that you always draw your 4 cardinal points. You must know that these 4 cardinal points, each of them is 90 degrees. So if you want to draw another point, you will always start from north to locate the bearing. Let me just start by solving this so that you will understand it. Now look at what I want to draw now. A boat sails 6 kilometers from a port X. So there is a boat from port X. So you have to locate port X. I will come to the center of my book because I don't know the direction I'm going. It's given in the question. But just come to the center and draw your 4 cardinal points. And in these 4 cardinal points, they said on a bearing of 65. This is what I want to see so that I know how to move. So I am going to move 65 degrees from the north pole. This is the north pole. This quadrant here is 90, so you know how to bring out 65. 65 will be around here. So it's like splitting 90s into different sizes. So you should know how to split this to have your 65 degrees. So this is my 65 degrees. From here down here, this angle is 65 degrees. So this is the direction that the boat moved, and it moved a distance of 6 kilometers, they said. Then on getting here, any point you get to, because they said thereafter, put your 4 cardinal point. Make sure your line is exactly at the center of that 4 cardinal point. Now at this point, now the boat is here. Say thereafter 13 kilometers, fine, on a bearing of 136. So I'm going 136. So at this point now, from north here is 90. Now for me to get 136, I need to add extra 46 to 90. 90 plus 46 will give me 136. That is the angle I need to cover. That is the direction. So in this second quadrant, you split it into 46 and 44. 2 of them will give you 90. So that will be around here. So what it means is that this place is 46. You must know all that. So you move. Now how far I move now depends on the length I decided to be 6 kilometers. You know, this is 13. Where is it? This is 13 kilometers. It has to be bigger than 6. So by your drawing, you have to make it bigger than 6. So this is 13. So this, I will draw another 4 cardinal points. Once they give you these two sides, this is 13 kilometers. Then you have to join from here down to meet. You use ruler, don't use free hand, so that you can join to the center of the 4 cardinal points. You always form a triangle. So this is the boat. The boat started from here, X. No other point were given as Y or Z, so you label it yourself. Move to Y, then Z. So this is the interpretation of this question. Now the next thing you will do before you start calculating at all is to find how many angles you'll be able to know. Now if they give 2 sides like this, definitely you will know this angle here. This is how I will know it. Now don't forget, this is 65 degrees and this is a line connecting to this quadrant, so it means this side is going to be also 65. Alternate angles. Look at this line and this line, they are parallel. They are not the line north to south, the line north to south. So this line is like a transversal. So this angle here is alternate to this angle here. Then to balance this place so that you know the entire angle here, don't forget this quadrant is 90. From here to here is already 46. So to balance it, 90 here has to be 44 degrees. 44 plus 45 will give you 90. Don't forget how we got this 46 is because you are looking at this entire bearing to be 136. So here is already 90. As I would know that here has to be 46. So we have succeeded in getting this size. 65 plus 44 will give us 109 degrees. So with this diagram, don't try to find here because you will not be able, because you don't know this size, this fraction here, you don't know this fraction here. So but with this and this and this, you'll be able to calculate the distance and the bearing. So with your diagram, you now locate where is the distance you are calculating. Definitely is the last leg of the triangle that is unknown. So what you do, don't forget the boat is here. The boat left from port X to port Y, thereafter from port Y to port Z. The question is now, what is the distance and bearing of the boat from X? So the question is saying that the boat is here. How far is the boat from the port X? So that is this point. I'm going to call it small letter y. Since here is capital letter Y, opposite it is going to be small letter. This is capital X, opposite it is X. Then this is Z, opposite is small letter Z. Now this is how I write my Z to distinguish it from 2. Now distance from X is the Y. That's the first question. Then bearing of boat from X. Now let's see bearing of boat from X. And this is where I need you to pay attention. Bearing of boat from X, when they say from, that is where you are. You are here. You want to sight the boat. So from the North Pole, that is what bearing is. Go to the definition of bearing I gave. It's always clockwise from the north. So when you locate this line that linked Z, it is this entire size. So this is the bearing of the boat from X. When they say from, that is where you are going to stand to draw the line, the arc from the North Pole to that point you are looking at. We want to look at the boat from here. So this is the angle. the bearing we want to calculate. Now here to here is already 65. So the logic is that we need to find this angle. This size of this triangle, call it theta. So if we get it, bearing of both from x becomes 65 plus theta. Now our business is to find this and this, and we have solved this problem. Once you get your theta, add it to 65. That is the bearing they are asking of. So let's solve it. So with the formula that I gave to get the distance using cosine rule, which says a square is equal to b square plus c square minus 2bc cos a. Don't forget. So if you are used to the formula with the variable ABC, all you need to do is to change it to suit your question. Here I'm calculating distance y, so my a will become y. Then in no particular order, BC can become xz respectively, xz. So this a here is y, capital letter Y. So the formula becomes y squared is equal to x squared plus z squared minus 2xz cos y to suit your diagram. Then replacing them, this is what you are looking for. Your x is 6 kilometer and 6 square. Your x is 13. Your z is 6 minus 2 times 13 times 6 cos your angle y is 109. So when you solve this, 13 is 169 and you square it, plus 36 minus, when you multiply this, 3 times 13 will give you 26. 26 times 6 will give you 156. 156, when you find cos 109, is going to give you a negative value. If you punch your calculator, 56. So when you compute this, don't forget, add these two separate. That will give you 205 minus, when you multiply minus times minus, is going to give you plus. Then multiply this to this, it's going to give you 50.7886. So when you add them together, it becomes 255.7886. Take the square root of both sides to get y as 15.9934 kilometer. That is approximately 16 kilometer. So the distance y is 16 kilometer. So the next is to calculate the bearing. So to calculate the bearing means to look for theta. Now to look for theta, when you have one angle already with the 3 sides known, you can use sine rule. It's more convenient. So using sine rule, now this is what I want you to always do so that you don't get confused. Just write all the side sine. You can use x this time around, don't use a. Just go straight to the point. It's equal to sine y over y is equal to sine z over z. All the three angles and all the three sides. These are you combine it. Fix their values because you are going to use only two pairs. Use two pairs in such a way that it's only one that you are looking for, that is the unknown. That is, this is sine x, that is theta. The angle there is theta. That is what you are looking for. Over 13 is equal to sine y will be sine 109 over y now is 16 kilometer. It has been calculated. Is equal to sine z. There is no angle here, z. So that is z over 6. So this is what you are looking for. We don't need this. There is another unknown here, so you discard this. So it's just these two. So you cross multiply. Leave your sine theta. Use 13 to multiply sine 109 all over 16. When you compute this, so if you compute this, sine 109 will give you 0.9455 divided by 16, so that your sine theta will be 12.2917 over 16. When you divide that, it will give you 0.7682. Now find the sine inverse. So theta will be arc sine of 0.7682. And if you punch your calculators, you press your second function, press sine, write 0.7682. That will give you approximately 50 degrees. Therefore, our bearing, we are not done. This is just theta. Our bearing of the boat from X will be 65 plus 50 degrees. So that will give you 115 degrees. So this is the bearing of the boat from X, this entire angle. So this is how to calculate bearing and distance. Don't forget, bearing is the angular distance of one point to another. Okay, if I draw a point here, X, and draw a point here, Y, the bearing of Y from X is, you have to join this line down. The bearing of Y from X, when they say from X, this is where you stay, and side is this entire angle, always from north. While the other way, the bearing of Y, bearing of X from Y, that is staying at Y to side X, is northish back, but also from the north clockwise, this entire size. As the bearing of X from Y. So take note. Thank you for listening.